So the subject of this talk is streams and things. You can see this is a Robo Sapiens, which has been hacked. It's got a Raspberry Pi for a brain. And this light pong, which is addressable RGB LEDs running Arduino. I didn't drag these in on the tube this morning because I broke my leg. So I've got a fractured leg. I've got a fractured tibia. My tibia plateau is kind of busted. I spent a lot of time in A&E in Charing Cross Hospital on Thursday. My leg's been broken for a month. I didn't realize it. I thought it was a bad sprain. I was busy. I've just changed jobs. I work for a very well-known American company called Ubiquiti Networks. Hands up, who knows about Ubiquiti? Very few. OK, these guys are the kings of wireless access points. So literally, we're building the Internet of Things. They build kind of wireless devices, microwave cannons, stuff like that. And, you know, your average, everyday home network kind of stuff on an industrial scale. I used to do lightweight messaging for gambling and gaming products. Anyone from the gambling gaming community from here? Yeah, it's that kind of stuff. But we're here today to talk about the Internet of Things. Who here has a definition of the Internet of Things that might be useful? Andy Piper.
All the devices connected to the Internet.
All the devices connected to the Internet. Who's got a different definition? Who's going to offer a different definition? Something more emotive, maybe. Less emotive. I don't know. No one?
Windows for washing machines.
Windows for washing machines. We've got a S&M corner clearly over here to the right. You may want to move over to the left where the conference will be better. Windows is awesome. X Windows. So the Internet of Things, really, it's actually last month, Oxford added it to the dictionary, is a proposed development of the Internet in which everyday objects have network connectivity, allowing them to send and receive data. So clearly, Andy has been in Oxford recently, because that's pretty much what he just said. Here's what I think the Internet of Things is. It's a proposed development of the Internet in which everyday people can easily network everyday objects, allowing them to send and receive data. And everybody understand the difference. It's not really about the things, is it? Who disagrees? You're wrong. Everyone else agrees. You all agree with me. And the thing we do with these things is, well, we stream events to them, don't we? OK, so this is really about events and streaming, the Internet of Things. It's about interaction with objects for some reason, at least in the way I think about it. So it's about streams of events. It's about receiving, processing, integrating, composing, mashing up data and events for some useful purpose or gain. OK, so there's nothing magic about the Internet of Things. It's a marketing term like big data. Things. Who here does not like things? Everybody likes things. Who has a problem with things? Andy, put your hand up. Thank you. I have a bad problem with things. Who wants to buy this thing? This is the Philips Hue. This is the world's most expensive and ridiculous light bulb. I'm serious, right? So you can go to the Apple store right now. Here's a screen grab I got the other day. You can get 3 light bulbs and a base station for the light bulbs, a base station for a light bulb, for £179.95. Who here is mad enough to buy one? OK, my wife's going to kill me when I get home because I'm thinking about buying one. I put the slide in. But that's not really very exciting to me. Here's something that's much more exciting. Who knows what this is? Light fidelity, or LiFi. These are light bulbs that are the Internet. It's an access point. It's a light bulb that you can use to get connectivity from. That is much more interesting, right? Who thinks it isn't? Awesome, you're all learning. You're onto my tricks, but they change throughout the talk. Here's another pretty awesome thing. This is a fairly boring household scene. Does everyone see the radiator? That's a supercomputer. I'm not joking. That's a supercomputer connected to the Internet. So this supercomputer is by a crazy French company called Carnot Computing. I got this off Kirk Wiley on Twitter the other day. I've been literally floored by this. So it's got a bunch of multiprocessor cores in the base on a custom circuit board, and you send it workloads from the Internet. It processes them and sends the results back. In other words, they're using supercomputer side effects, the thermal heat exhaust from supercomputers, to heat your home. That's much more awesome than Nest, which is a shiny light bulb-like thermostat, right? That's crazy. That's awesome. That's the Internet of Things, put to industrial use to heat your homes and keep your wee ones nice and warm at night. This is the Internet of Things about people, and that's very interesting. Here's another crazy thing. We happen to have one here. It's the Parrot Aor Drone 2.0. Who has one of these things? It's awesome, isn't it? And it's designed to work with a mobile phone, but this is the flying wireless access point. Yes, someone took your router at home, your wireless internet access point, put 4 motors on it and some blades, and decided to fly it. And it's connected to the internet, so you can network these things. There's lots of communities cropping up that actually hack these things. So there's Nodecopter, there's a Clojure version, there's a Java drone, I believe. And I'm currently rewriting a client for this for Erlang, which is my favorite language. So there will be an Erlang copter at some point, no doubt, on the JVM. It's pretty cool. This is a flying device, an Internet of Thing, that provides internet access. Typically, you run it on a closed network, but it's got 7 or 8 different protocols running on it. You can telnet into it. You can upgrade the Linux environment on it. It's eminently hackable. Which brings us to streams. Okay, so why are we connecting? Why are we joining all of these things together? To get some derived value from them, right? In the case of a heater, that's also a supercomputer, you're deriving heat, so you're getting a real transactional value from this. It's heating your home. It's also curing cancer. That's pretty awesome, right? So really, the Internet of Things is about people. And people, like us, developers, we have a responsibility, don't we? Who here actually writes code every day? Okay, most of you are at a conference in the middle of London on crazy Java programming stuff. So most of you go home at night and you still code, right? Who does that? So maybe you use a different language at night than you use during the day. Maybe you use multiple languages during the day. It doesn't matter. You're compelled to write code. So we have a responsibility with this Internet of Things to make it accessible. And I know one crazy environment where that's actually in use today. Who knows about an algorithm called Paxos? It's for distributed systems. It's hard, isn't it, to write Paxos? That's Paxos in a visual language. I implemented that a few years ago because I thought I'd try to see how far I could take complex event processing, stream programming. It was crazy. But it looks really nice and simple, doesn't it? I mean, a 5-year-old could program Paxos. Well, maybe Raft, because it's easier. But this is not about distributed systems. This is about streaming. But this is a nice visual language. You can see, if you read this left to right, where things start, where they get processed by something, and where it ends up, right? You can see it flowing left to right. You might be more comfortable with textual languages like Java, right? So anyone here of Node.js? Who loves it? I think it's an awesome language, even though it's different. Everyone still hates it. OK. Even though you hate it, they've got this really cool thing called streams and pipes. So you get a stream A, you can pipe it to B, and then pipe it back in through A again. That's a bidirectional stream. It's designed for I/O and high throughput, and it works quite well in Node.js. It's quite an interesting construct. It's very easy. It's just using the builder pattern. So who's read Debashish Ghosh's book on DSLs? Read his book, guys. It's awesome. It's the builder pattern. Check it out. Everyone's using it. So a guy called Max Ogden in the Node community has a stream and pipe algorithm like this. This is essentially doing binary batches of data and chunking them into LevelDB. It's very, very efficient. You might think JavaScript is slow. This will force you to reconsider those considerations. It's doing about 50 megabytes a second of throughput into a database, into LevelDB, which is pretty impressive for those who think JavaScript is still slow. JavaScript is quite fast these days. For computational workloads, it's only 5 times slower than Java. Believe me, that's fast enough to saturate your 10 gigs, so it's not as slow as you think. But I'm here really not to talk about streams and things. I'm going to talk about event processing, or processing these streams to do something useful. And in a minute, we're going to fly this quadcopter with streams of events, because that's crazy. Or maybe one of you are going to fly the quadcopter. I'm going to pick someone at random that hasn't been trained beforehand. OK. So to process streams of events, we can use an embeddable subset of CEP. Who's used CEP engines, the complex things they use in capital markets, right, the visual languages? How do you find it as a programming environment? Would you prefer writing raw Java to this visual language most of the time? So you're writing SQL queries in the Asper case. But there's visual languages. The visual languages are flow-based. It's kind of like a visual SQL anyway. There's kind of the same difference. But you tend to want to use it for very specific tasks where you have complex events and you want to structure them or process them in some way. Most of the time, you actually want to write Java code or code using your native language. Now, I've got an open source project on this. kind of an accidental open source project. I thought CEP was scary, so I wrote a project called ETH, which is not scary. It's really simple. It's on GitHub. It became quite popular, so people started porting it to Clojure and PHP. I ported it to Erlang and Java. And there's another little language that does this flow, branching, and combining, which is called Beam. And as I'm a practitioner of conference-driven development, who does conference-driven development? If you're going to a conference and you're speaking, you have to produce open source. That's it. So I'm speaking at this conference. I had to write an open source project, which is Beam Java, which we're going to go through today. Awesome. So everyone goes home with something virtual on GitHub, a URL. OK, so in Beam, it's a simplified subset of CEP. So we have sources, where we get data from, sinks, where data goes to die or get processed or go to an external system we don't care about. We have operators. They process things. They transform or filter data. We have pipelines of these things. OK, so we can set up chains of events. And that might look a little bit like this in real code. Can everyone see the code here? Everyone go, no, it's too small. At the back, at the front? It's good at the back. There's one guy with 20/20 vision at the back. He must be younger than everyone else. So here we have an input stream. We're filtering that data to see if it's even. And if it is even, we process it to the output stream. So if you're sending in a monotonic sequence of data, you'll get half the data out the other side. Make sense? So you create a filter, you construct this pipeline, and you process data through the pipeline. It's very simple. We could transform data. Okay, so we could take the data and we can square the data that's arriving in. It doesn't have to be a long, it could be an arbitrary Java object in this case. Okay? We have built-in functions, so I can write these libraries of operations I can perform on data as it streams through a system, and I can reuse them, so I can compose more complex queries over time as I build these libraries. Okay, so it's quite a powerful construct. You're building a very small processing engine that does one thing and one thing well, and you're extending it with domain knowledge in ways that are orthogonal. Right? You're not making the core constructs hard. This is one of the failings in commercial CEP engines. They have things like aggregate window processing, but they have multi-dimensions, so it's hard to think in more than 2 and 3 dimensions, especially when the CEP engine you're working with got the damn thing wrong, and it doesn't compose with things like grouping or partitioning or ordering. So if you leave all of these hard things out, you get 2 beneficial effects. The resultant infrastructure is really simple, and even a child can understand it, which, as we'll see in a minute, is quite important for the Internet of Things. But also, you can actually make it run really fast. We can exploit mechanical sympathy in various ways you can't do with the more complex arrangements or infrastructures. So we also have branching, okay? So in a branch, I might take a list of things and split them into evens and odds and then process them downstream separately, so in parallel, if you will. I can combine things, so I can have multiple streams of events. I might want to merge, combine, or union them in some way. And we merge them into a stream, and then we can operate on that merged data. For example, we can plug in our own custom operations. Or we can fly quadcopters with them. So we can take CEP, which originally came from log analytics and kind of got popular in capital markets, and we can fly a real-time device with it and hopefully not kill anyone. But if you look at this structure, right, you can see how you can develop graphs of things with this particular piece of infrastructure. This is not far from one of my children's favorite programming languages, Scratch, where you define these flows. This is a brilliant high-level language that opens up complex activities to people that are quite simple. And I think that is probably one of the most brilliant tools I've ever seen, and I love it as much as my children do. So can we make complex Internet of Things, things that are traditionally associated with developers, and can we open it up to the masses? Can we actually do that? And can we use tools like this, even though it's not ideal for us? We want to drop into code. We want to write it in Esper because it does this thing or that thing, or we want to write it in Java because we're programmers and we understand at a deeper level maybe how to do things. But why can't everyone else use a language like this and an infrastructure like this to take the things in their lives, the robots, quadcopters, and mash them up to make their lives better? That's really what we should be doing. So who wants to fly the quadcopter? Windows man, come here, come hither. What's your name?
David.
David is going to fly the quadcopter today. Because really what we care about is people and things. Okay, so we want to take simplicity of an educational tool like Scratch and empower ordinary people like David the Windows programmer to do amazing things. Okay? I feel like Steve Jobs now, just making you awesome. Someone should buy you a Mac next. Like your life would be complete. Okay. He said. Okay. The controls for this are actually very, very simple. So you're going to use my laptop. And if you flip over to the terminal there, you'll find a little program. I'm not even going to help you. I'm so confident you can do this and not break my expensive quadcopter.
I can't operate an expensive Mac.
Oh, damn. Portability issues. Tell you what, you hold the expensive copter, mind the blades might move. Don't hold it near your face. Okay. And I do have some sound here. Cue to the audio, guys. We're going to take off as soon as that is... Dude, it's going to take off. Get it out of your hands. So when I fly this, you'll have cursor key controls, W, A, S, and D. There is an emergency button, which is the space key. If something bad happens, please hit the space key. Everyone in the audience, this has been designed for your safety. When I was debugging this last night, I forgot that feature, and I killed a couple of plants. Killing plants in my house is bad. My wife doesn't like that. So if something bad happens, what do we want him to do, audience? Hit the space key. I don't think he heard that, OK? Let's say it twice just in case. Let's be fault tolerant about this. Sorry, let's not be tolerant about this. Let's be intolerant about this. What do we do if something goes wrong? I think David got the message. OK, so it's on. In order to take off, I'll just start that program on the left. Don't do it yet, it's in my hands. Safety first. OK. And before you run the program, I'm going to get out of Dodge. I mean, I'm going to move over near you and use you as a barrier. OK. You may control the copter.
Flying forwards. Flying forwards.
It's not flying because we're not connected. I forgot a step. I always forget a step. Because I connected to the wireless network here. This is a flying wireless access point. So clearly Park Plaza Hotels and Resorts is not a flying thing, right? I wanted this one. Yeah, the hotel ain't going to take off. That's why nothing happened. This is not a flying saucer. There we go. All right, so if you want to fly up, hit the up cursor button.
Flying forward, flying backwards, flying backwards, flying to start, flying to port. Flying, flying up, flying forward, flying forward, flying forwards, flying forward, flying backwards, flying backwards to start, flying forward,
One command at a time.
flying forward, flying backwards.
It died. Thank you, David, for your gracious flying. Okay. If you buy one of these things, it has a dead bug mode, which is awesome. You just hold it upside down. So if this is actually flying towards you at a real conference, not a crazy conference like this, turn it upside down and it won't kill you or hurt you. Try not to touch the propellers, that hurts. OK. People and things. Streams and things and the Internet of Things. Is it about things? No. What is it about? It's about people. So it's about empowering people, right? So what do we have as developers? What do we have a responsibility for? Not keeping all the cool toys to ourselves. Because there's a big danger we're going to do that, right?
Empowering people.
Empowering people, right? With skills we have that we can produce through building better products that are more hackable. And I think the Internet of Things, streams of these things and the events that result, is an opportunity to do exactly that. So rather than coming to conferences and talking about big data and other things, we can talk about empowering people and the value that offers. Or putting a smile on kids' faces because they can fly a quadcopter with Scratch, which is awesome. That's it for me. Thank you very much. It's been a beautiful audience.